Okay, this is good. I'm gonna look. Let's go.
Okay. Yeah, we're ready. Okay. Hello, everyone.
Welcome to another webinar. We're going to talk about science stuff today. I know electricity was originally scheduled, but I'm switching that to Monday. What we're going to talk about today is climate. So for all of you guys waiting to hear more about electricity, I have a great webinar on Monday, and you will see some things you probably are not familiar with and learn some new fun stuff. But I wanted to welcome you today. This is my friend and recent graduate, Simon, because
Hello, everyone.
James is doing a current events seminar.
Sam? What about Sam?
Sam is not doing these things these days.
Oh, well, yeah.
Anyway, if you have any questions, send them in on the Q&A box. You know the routine.
Mm-hmm.
And Simon will read some of them off if he feels like it,
Yeah.
or if they're interesting. And I hope you learned something today. So today we're going to talk about climate and weather and all of that good stuff. So the word climate comes from the Greek word klima, and that means a region or area. So the climate is the weather in some region or area or part of the world. And weather comes from the German word Wettrum. You didn't know that, did you?
No.
And it means a storm or wind. So the weather is what we're having now.
Right.
Or the weather in the next couple of days. You know, someone is forecasting or predicting the weather. They're predicting what it's going to be in a day or two now, but they're not predicting what it's going to be like over the course of the year. That would be climate. So sometimes people get those two things confused. So I thought I'd sort that out with you right from the get-go. Here it is. We're feeling kind of tropical. Yeah. There's a nice breeze, isn't it? I wish the weather was like that here, but it's not. We have cooler weather. And we're going to talk about some of the factors or some of the things that will determine what the climate is going to be like in your neck of the woods. So some factors include the altitude. That means how tall, how high you are. Mm-hmm. If you're up high on a mountain, it's going to be a different climate than if you're at sea level or below. Of course, the temperature, and of course, the rainfall or snowfall, and winds. So those are the four things, the main four things. There are other things that will help determine the climate or even the weather, but those are the main four things. And of course, any discussion of the Earth's temperature has to take into consideration the sun, our very own star. I think we have a picture of the sun, Simon. Could you bring that up?
Yeah.
That's the one. Yeah. Boy, it looks even hotter now, doesn't it? Yeah. So this is our star, the sun, and we're going to talk briefly about how the sun works, how the sun gets its energy. You know, in the old days, scientists thought that the sun was burning. It was like burning wood or burning some fuel, burning gasoline or oil or something. And that's not actually how the sun gets gives us heat. It's not a burning, it's a nuclear reaction. So when I talk about nuclear reactions, I'm talking about the nucleus is the inner part of the atom. And you have the lightest atoms are hydrogen. And you have two hydrogen atoms that are sort of fusing or melting together and forming helium. As a matter of fact, the word sun comes from helios. Helios is the Greek for sun or for helium. So helios is the Greek for the sun, the helium. And you can hear that word is still used today, heliocentric model of the solar system means the sun is the center, which is the way it is. A geocentric model would be where the Earth is the center, which was what it was thought of hundreds of years ago in the old days. That's another webinar. Anyway, this process,
Marty,
yes.
someone's late, so could you like give a?
Nah, you should catch us in a few days. Don't be late. Okay, we're talking about the weather and climate and the sun. Okay, so the sun forms hydrogen come together to form helium. In doing so, a little tiny bit of matter is changed into energy. And Einstein did a famous equation that you might have seen before. It's E equals mc squared. And what that famous equation means is a little bit of matter can create a huge amount of energy. So let's take a look at the next picture we have up. Da, 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 da. That's the one. Okay, that is fusion. Fusion is this process whereby two hydrogen atoms, so there's a hydrogen atom, hydrogen has one proton.
Mhm.
So there's hydrogen atom with one proton and one neutron, and a hydrogen atom with one proton and two neutrons. Neutrons don't really make a difference in which element it is. It has one proton, it's hydrogen. And it forms helium and gives off a tremendous amount of energy. So that's what's happening. You've probably seen Diego's videos on space and stars. This is what's happening on every star, including our very own star, the sun. And this is what heats up our planet enough so that life can exist. If it wasn't for this process, this would be an uninhabited, very cold rock floating around in space. Okay, so now we're going to talk a little about temperature. So what determines temperature? Well, the sun, of course, and sunlight. We get sunlight. The sunlight comes in, travels through space and comes to Earth and heats up our planet. And of course, planets closer to the sun are warmer, and planets further from the sun are cooler. But here's a strange fact, and maybe you can guess why this is. We'll talk about it. In the wintertime here in good old Oregon, the sun, we are closer, the Earth is closer to the sun than it is in the summertime. What? Oregon is closer to the sun in the wintertime. And in the summertime, Oregon is further away from the sun. How can that be? This is something called counterintuitive. And that word means counter is against something. So it's different from. So counterintuitive has to do with intuition or the way you'd normally think something is. So the fact that Oregon is closer to the sun in the winter is counterintuitive. You'd think, well, if a planet is closer to the sun, it's warmer. It's warmer in the summer. So obviously, Oregon should be closer, Earth should be closer to the sun in the summertime, but it's not. There's about 3 million miles difference. We're about 91.5 million miles from the sun in the winter. And in the summer, we're 94.5 approximately million miles away from the sun. We're further away from the sun. How could that be? Why is that so? Anybody answering?
It's because the sun can heat up the Earth for a longer time when it's farther.
The sun can heat up the Earth for a while, but that's not the reason. Do you know, Simon?
No.
No, I know. Okay. So
You wanna tell
I'll
them?
let you.
You want to tell them?
Nah, sure.
Oregon faces the sun.
Oregon faces the sun. I don't know what that means exactly.
And because it faces the sun.
It faces the sun.
Oregon? Or,
Oregon
sure.
faces the sun. Well,
and Oregon has lots of mountains.
that's true, but that doesn't have anything to do with why it's warmer. Oregon is warmer in the wintertime when it's warmer in the summertime when it's farther away from the sun. Isn't that peculiar? So if you're ready, I'll tell you why. This is my handy dandy laser. And it's a green laser, as you can see. You can see my green laser. So I'm gonna take my green laser and I'm gonna point it here. And you see the size of the, I don't know if you can see that. Oh, it's green. You guys can't see green. Okay.
A little bit.
A little bit. So I'm gonna have it here. Can you see it here?
Not really.
Not really.
Yeah, look.
Okay. It's a green laser. We can't see green because we have the green screen up. But if this was a laser, or let's say a sunbeam, and it would land right here, because the sun is coming in at a certain angle. And if the sun was coming in at another angle like this, it would spread it, that beam of light which will heat up the earth, will be spread out into a larger area.
Well, you know what we can do?
What?
We can turn off the green screen.
We can turn off the green screen. We're going to turn off the green screen for just a second so you guys can see
here
this.
we go.
Can you see it now?
Yeah, we should be able
So here's the dot. Can you see the dot? They still can't see the dot.
Yeah, they can.
You can?
Can you guys see the dot? But I can see it on your hand.
Okay. So now, can you see
Yes,
it?
they can see it now.
Can you see it here? How it's so much
Spread out.
taking up a lot more area. So when it takes up a lot more area like that, it's not as bright. It's not as hot. And so you put the green screen back up. I'd like to be tropical.
Yeah.
Thank you very much. So here, here's good old Oregon or the US. And so at this time, it seems like the sun is hitting this part directly. This is getting the concentrated energy of the sun. And here, at this point, it's sort of spread out. And that's why this part's cooler. And yet in the winter, that was winter for us. So isn't it strange when it's winter for us and we're huddled around the fire or go skiing or something like that? People in South America will be going to the beach, eating watermelon, having picnics because it's hot down there. Anyway, here, 6 months later, now the Earth, the north part of the North Pole, we could say, is pointed toward the sun. And so we're getting the rays more directly, the sunlight more directly. And here in poor South America, they're getting the sunlight, but it's not as concentrated.
Right.
And so when we're going to the beach in June and July, they're huddling by the fire and eating warm soup. Anyway, let's take a look at another picture we have.
Someone's late. We're talking about
We're talking about climate.
Climate and weather.
Yes. Okay, so the next one is, ta-da. So it's all about the tilt, because the Earth is tilted as it goes around the sun. If it's tilted toward the sun, the northern hemisphere is tilted toward the sun, then this part, the northern hemisphere, will have summer. If the northern hemisphere is tilted away, then we're going to have winter.
Right.
Okay, one more picture.
One more.
That one. Look at that. See, in January, we're closer to the sun.
Mm,
Perihelion means close, the point of the orbit,
right.
which is closer to the sun.
Much closer.
So you think that most people draw the Earth's orbit around the sun as a circle, but it's not quite. It's kind of a squashed a little bit, called an oval or an ellipse, if you want the fancy word for it. Anyway, you can see that the Earth is closer to the sun during the winter and further during our winter in North America, in the Northern Hemisphere. Same thing in Europe. And it's closer to, when it's close, of course, it's closer, that means it's closer during South America's summer. Anyway, I thought that was interesting. That's counterintuitive, remember, against what you would normally think, the opposite of what you would normally think. So, on to our next thing. We're going to talk about altitude. So, I know here we have Mount Hood. Have you ever been to Mount Hood, Simon?
No.
You've never been skiing?
Never.
Okay, neither have I, but I've been to Mount Hood. I'm not a skier. I'm sort of a lodge bunny, but that's another story. So we're going to talk about altitude, and altitude is the height of something.
Oh, Marty. Someone asked, I thought we're talking about
Magnetism.
Yes.
I know, I switched it around.
Yes.
That's going to happen Monday. It's going to be, I think, one of my favorite webinars, but it's going to be on Monday. So if you don't want to learn about climate, I'll see you Monday. Anyway, here in Mount Hood, I know sometimes in the summer, it's like 90 degrees here
Really?
in Oregon.
In summer, yeah.
You've been here in the summer, right?
Yeah.
It could be like in the 90s, and yet on Mount Hood, there's
Much
snow.
Cooler, right? Yeah.
There's snow. 90 degrees here, Mount Hood, there's snow. It's because, and you'd think, well, I talked about how when planets are closer to the sun, they're warmer. So you'd think up on a mountain, you're closer toward the sun. So you should be warmer, right? Not exactly. So even though you're closer to the sun at high altitudes, maybe by a mile or 2 or 3, sunlight passes through the air and doesn't heat it up. It heats up the ground. It heats up solid things. And when it does, then that sunlight turns into heat. So you could have a plane flying through the air and it's cold up there. And yet when it lands back down on Earth, it could land someplace that's really hot because of that fact. It's the sunlight is changed into heat when it hits the Earth or hits a solid object. And space is very, very cold. So when you're out in space, when you're up on a mountain, there's a lot of empty space, which is very cold.
Right.
That's another reason why they're up on a mountain, it's cooler. Okay, so you've been to the beach here, Simon, in the summertime, when the sand is really, really, really hot.
Yes.
Why is if you go into a wet sand or a little shallow pool, is it as hot?
No.
Why do you suppose that is? Why do you suppose that in the summer, no matter where you are in the summer, if you go to the beach and the sand is hot,
Right.
you go onto the wet sand or you go onto a shallow pool of water and it's much, much cooler. Why? Why is that? You have any idea?
The water cools it down.
The water cools it down. Right? Why? How come? Why do you suppose the water cools it? I'm not talking about the ocean water, which is very deep and waves and that sort of thing. I'm talking about just a little bit of wet sand compared to dry sand. Why is the wet sand so much cooler? at the beach or anywhere. And why do people go to the beach to cool off? What's that about? I mean, I've been doing it since I can remember. If it's a real hot day, you drive to the beach and it's cooler there. So the answer is because it takes a lot more heat to raise the temperature of water than it does to raise the temperature of sand. So I could have a patch of sand here and a patch of water, and sunlight falls down on the two of them, and the sand is going to get a lot hotter than the water. It takes a little bit of energy to heat up the sand compared to the amount of energy it takes to heat up the water. Right. And that's why in the summertime, people go to the beach because they know at the beach it's cooler. As a matter of fact, it's in the coast, it's a lot warmer in the summer, warmer in the winter. So we could be having snow here in the winter, and at the coast, it could be a lot warmer. And that's the same reason. It takes water. Water holds on to the heat. Remember, it takes more heat to change the temperature of water a few degrees.
Right.
But once the water gets hot, it holds onto that water. It holds onto that heat a lot better. And that's why people go there in the summertime to cool off, because it's cooler there. It takes more heat to heat up the water, to raise the temperature of the water. And in the wintertime, the water holds onto the heat better. Anyway, have you ever, you wear shorts in the summer?
Yeah.
I wear shorts in the summer. Have you ever sat on a metal seatbelt buckle when you're wearing shorts in the summer?
Oh, yeah.
Why is that so much hotter? It feels like, yow, something's burning. When when the skin on your leg touches a seat buckle, a metal buckle. Why is that? Why is that metal buckle so much hotter than the rest of the seat? If you think you know, send in the Q&A and we'll see what we can do.
Yeah. Metal traps more heat.
Right. Just as it takes a lot more heat to raise the temperature of water, for metal, it just requires a little bit of heat and that temperature goes up really high, really fast on metal, a lot faster than, let's say, your fabric seat on a car seat. Now leather can go up pretty quickly. So if you have a leather car seat, it can get very hot very fast. Maybe not as hot as the metal buckle, but pretty hot, pretty fast. Okay. So we talked about how things could be warmer when they get closer in the northern hemisphere.
Right.
They're warmer when they get closer to the equator. And but that's not the only factor besides altitude. Now, altitude's another factor we talked about, but there's a third factor, and I'm going to tell you what that is right now. So, Buffalo, New York is closer to the equator than Sheridan, Oregon. That's where we're from. We're in Sheridan, Oregon.
Yep.
Buffalo, New York is closer to the equator. So you'd think in the wintertime, it should be warmer. Let's take a look at Buffalo at the next two pictures. Buffalo has an average snowfall of, next, down, down, down. Keep going. And there's Buffalo. No, that's Buffalo Oregon in the winter. Nope, there. That's Oregon in the winter. Western Oregon, 4 inches. Go back up a little bit. There is Buffalo in the wintertime, 94 inches of snow every winter.
Okay, Marty. We have
Yes.
questions here.
Yes,
So they're asking why black objects gets hotter than white objects.
because white objects reflect the heat. So if you have something white, it'll come in. You can see colors and you can see light. For instance, I'm going to look at this. You guys see this blue? Is this a blue? There's a purple. Is that purple?
Yes.
Okay, there's a purple. Remember, I'm red, green, colorblind. Anyway, there's purple. So what happens is the white light hits this and bounces off some of the colors, and my eyes see them as purple. Same thing with white. If I have a sheet of paper, like the table, light comes in, hits the table, bounces off, hits my eye because all the colors are being reflected.
Mhm.
Black is an absence of color. You go into a dark room, I mean, no light at all, like a closet. You go into a closet and you have a piece of paper in your hand. Can you tell what color paper that is?
Nope.
No, it all looks black because
Yeah.
black is an absence of color. So what happens is if you have something black, the light is hitting it and it's absorbing all of that heat. And it might reflect a tiny little bit. Maybe it's a little shiny or something like that.
Right.
But most of that light is being absorbed by the black paper or black leather chair or black whatever.
Right.
And that's why it's hotter. It gets hotter. That's why it looks black, because it's absorbing those things. That's why sheiks, Arabs in the desert wear white. You don't see them wearing black,
Oh yeah.
because if they did, then their clothing would absorb that heat and hold on to it. They're wearing white, so the sunlight will hit it and bing,
Reflects.
bounce right off.
Mm-hmm.
So that's why it does that. That's why, I hope that answers your question. Any other questions, Simon?
But Costa Rica is right next to the equator and doesn't get snow. Doesn't get snow.
That's right. You're right, because it's close to the equator. Now, there's one country that has a capital that's right on the equator. Capital city would be right on the equator. So it's like Washington, their Washington, D.C., or their whatever.
Mhm.
Their capital city is right on the equator, and that's Lima, Peru. But it's not that hot because it has a high elevation. Anyway, let's go back to Buffalo and good old Oregon.
Yes.
So why is it that Buffalo is closer to the equator than Sheridan, Oregon, but 94 inches of snow is the average? That's almost 8 feet of snow every winter. Great if you love winter sports, not so great if you have to drive or shovel. Anyway, why is it? There's another thing that's counterintuitive. It's against what you would normally think would be. You'd normally think closer to the equator is warmer. So there must be some other factor other than being close to the equator and altitude that will affect climate.
Mm-hmm. Elevation? they say?
Nope. It's at a low elevation in good old Buffalo. Well, it's because of the wind.
Mm.
Do we have a picture of the US somewhere? Ah, good. So here, we're getting our weather from the west. Because of the way the earth is spinning around, we get our weather from the west. As a matter of fact, if you're in New York or New Jersey or some East Coast cities,
Mm-hmm.
you can look and see what's happening in Wisconsin and Michigan and Nebraska, and that's the weather that's coming your way. Because of the spin of the earth, you have the weather coming from the west and going toward the east. And so take a look at Buffalo, New York. It's right by the Great Lakes. Do I have a, well, you see the blue lakes there just by
Is
New
there another
York?
picture?
Nope. So what's happening is in the wintertime, the cold air comes down from Canada, picks up some moisture from the Great Lakes, and then it goes over to Buffalo and lets all of that moisture out. And that's why Buffalo is so snowy. Now, in Oregon, we're getting warm air from the coast because remember, it takes a lot of heat to warm up the ocean. And so I've seen pictures of ponds that freeze, and I've seen pictures of some lakes that might freeze, but the ocean, I've never seen a picture. Well, it freezes up near the North Pole. That's where you have all of that ice. There's no continent, there's no land under the North Pole. It's all ice. But except for the North Pole and the South Pole, there's land under the South Pole, but even a lot of the water around the South Pole freezes in the winter. Mm-hmm. But in the middle latitudes, when I say latitudes, I'm talking about these lines. These are the latitude lines. So this is northern latitude. Here's the equator. This is southern latitude. Anyway, at this latitude, the latitude of Oregon and California and the whole US, we don't have the ocean freezing. And so you have this warm water coming and absorbing some liquid from the water, mm-hmm. but then it just rains when it wants to let that water go because the temperature is warm. Mm-hmm. Now, if it has to go over a mountain, then the cloud, let's say this is the cloud and here's the mountain. Okay, so the cloud has to go up high to go over the mountain, and it gets colder up in.
So it snows.
So it could snow. It could be rainy on this side of the mountain, but snowy on this side of the mountain. Mm-hmm. Anyway, we're going to take a look at two other places here. Let's take a look at the picture of the Central Valley in California.
This one?
That's the one. The Central Valley of California produces about a quarter of the food and half of all the fruits and nuts in the US. Why is that? Well, it's low, it's a valley, so it's low in altitude. Mm-hmm. It has water all around because it's a valley. There are mountains and the mountains get snow. And in the good old summertime, the snow melts and forms rivers and fills up the rivers more. And that's what plants and fruits and vegetables need. They need warm water, mm-hmm. good soil, and they need heat. And so you have those things in the California Valley. Mm-hmm. Now, 1,200 miles to the east of the Central Valley, it's about the same latitude, but it's different. Let's take a look at that picture. Okay. Here it is. Texas. Next 22 miles, absolutely nothing. So why isn't something growing? It certainly would be warm enough, but look at that soil. That doesn't look like it's too warm. It's too hot, and there's not enough water.
It's just desert.
Right. If you can get water, you can make this land produce things other than those cactus and little shrubs that are around. So there's such a difference between the two, even though they're at the same latitude, because of water. Water is so important. Okay, now we're going to talk a little about air. Warm air rises, like in that picture.
Yep.
And when it rises, do you know there's about 14.7 pounds of air for every square inch? Oh. So if you went from here at sea level all the way up to where the atmosphere ends, and you were able to weigh all of the air because gravity is pulling down on that air, right. It weighs 14.7 pounds for every square inch. Wow. So that's why if you have a balloon
It floats.
a helium balloon,
Lighter.
and you let it go, it goes up and up and up and up. But then once it gets bigger and bigger and bigger, because the pressure is less. There's less air pushing in on it. And it could get so high that eventually it pops.
Mm-hmm.
And that's why astronauts have to wear spacesuits.
Spacesuits, yeah.
If they didn't wear spacesuits
Their eyes
and
would
there's
come
no
out.
pressure, their bodies would pop like popcorn because there's a lot of pressure they have on the inside, no pressure on the outside, but here we're used to it. So we have the same pressure inside our body as outside. Anyway, this is what happens with air. Just like a balloon, just like you can take a balloon, a regular air-filled balloon, and if you heat it up, it gets bigger. And it gets bigger because warm air expands. As a matter of fact, I don't know if you've ever been in a hot air balloon. Have you ever been in a hot air balloon?
No.
I was in a hot air balloon once. It's very strange because you're up in the air and it can be perfectly quiet. No sounds except the wind. Anyway, that happens because they take this air and these balloons are really huge and they fill it with hot air. And there's a hole on the top of the hot air balloon where the extra air can go out when it expands. And they're so big compared to the people and whatever, the little basket underneath, that it's lighter than the air. So it goes up, the air gets cool, it starts to come down. The person there running the hot air balloon has this lever that they can push, and this big flame of propane burns, or some other gas, some other flammable gas, and it heats up the air again, it gets a little lighter, and it goes up, and that's how they can control the height, because warm air rises. Now, let's take a look at our next picture.
Next picture?
Yep. So here we are. You ever notice how if you want to have some tea or coffee and you want to add sugar to it, you could dissolve a lot more sugar in
hot water.
Hot water, exactly. And so it's the same with rain. If you have hot air, it'll dissolve a lot more water. And so what happens is when you have this air expanding, there are less particles pushing down. So it's called pressure. That's low pressure because things get expanded and because they're warm. And so that's low pressure. So you might have seen some weather maps or heard the weatherman talking about, well, there's a low pressure coming up from, that's what they're talking about. They're talking about it was hot. And you can see right here on the picture, it gets hot, it absorbs a lot of moisture. And then if clouds get high, if they get high, remember, the higher you go, the cooler it is. So then you could get to a certain point where the air is so cold, it can't handle that moisture. It can't carry it anymore. And so that's where you get rain.
Marty, we have a question here.
Yes.
So how is it that the hot air doesn't escape before the balloon was inflated?
The hot air doesn't escape. It does escape, but you have to, here's what they do. They take a hot air balloon and they have a big fan here, maybe this wide, and they blow it up with cold air. And of course, it's lying on the ground. And then once it's blown up, they turn on the propane jets and they take that air and they heat it up. And as the air gets hotter and hotter, it rises. And now the hot air balloon is just standing straight up, but it's on the ground. And then everybody hops in, and then the guy presses the trigger, and it gets hotter and hotter, and that's when it starts to go up. And we want it to come down eventually, so there's that hole there on top, but the pilot, I think you need a pilot's license for a hot air balloon. Anyway, the pilot can adjust the shape of the hole to make it bigger or smaller
Mhm.
and do various other things to keep it up. But you have to keep hitting that propane gas and heating up the air. Otherwise, it'll eventually come back down. Okay. Now, remember earlier we talked about why people go to the beach in the summertime. Let's take a look at that next picture. There's a blank. Good. No, we don't want the blank. So there's a sea breeze. So remember when the air, when it's cold, like over the ocean takes a lot of heat before it raises the temperature a little bit. The air is cooler. And the land heats up a lot faster than the ocean, just like we talked about the sand heating up and the wet sand not heating up so much.
Mhm.
So what happens is you have this breeze because the warm air over the land rises, and now there's not as much air down here
Mhm.
so as the air over the ocean, and so you get this breeze coming in, an ocean breeze.
What do you have more question about the air balloon?
Sure.
So if there's a hole in the top of the hot air balloon and the air keeps escaping, then how does air come back in to get heated up again?
Oh, at the bottom. At the bottom, there's even a bigger space where air can come in. And so it does that. So let's say you're starting to come down in your hot air balloon and you want to go back up. So the pilot presses the lever, it turns on these huge flames. And so air can come in just above where the pilot and the people in the basket are. And because it's hot air in there and it's less dense, so the denser or heavier air can come in from around it and go in. It's really cool. If you've never been in a hot air balloon, it's certainly different because you're up in the air, you see things totally different from the ground,
Mhm.
and it's perfectly quiet. There's no sound other than the sound of the wind. It was really a lot of fun.
Mhm.
Oh,
We have 2 minutes.
we have 2 minutes.
Yes.
Okay, so here's, there are a couple of weather symbols I want to show you. If you've ever seen a weather map, you might see something like this. Those triangular shaped parts are telling you it's high pressure. So why would it be high pressure? Well, it's high pressure because it could be a little cooler. And remember, when air gets cooler, it shrinks. It doesn't take as much space or volume. And so the pressure, the weight of all the air is more because the air is shrinking and taking up less space. The low pressure is shown either in red or with these little half an egg shaped guys. And what that's showing you is it's low pressure, which means it was warm, but now there's lots of, so the air expanded, there's lots of moisture usually in there. And so when there's lots of moisture, because it was hot and absorbed some water, that's the time you can have rain and cold. As a matter of fact, let's take a look at our final slide. And so here's an example of a low pressure system. Remember, low pressure usually means water.
Right.
There's water in clouds. And when it hits a high pressure, you can see it rains, because if you have warm air with lots of clouds and lots of moisture, and all of a sudden some cold air is coming in, that's going to drop the temperature. And just like we talked about your tea and sugar or coffee and sugar, now that hot, moist air can't hold the moisture, can't hold the water because it's getting too cold.
Right.
And that's when you can get rain and snow.
Mhm.
Okay. Well, I hope you can join. I hope you had fun and learned some stuff.
Yeah.
And I hope that you will see other videos. Do we have the website where students could see other videos?
Yeah, it's on YouTube.
It's on YouTube. We're on YouTube. I think James.
Delphian School.
Okay, YouTube/Delphian School.
Yeah, just search up Delphian School and you'll find us.
Okay, So you can do that, and I hope you can watch some other videos, or if you missed some of this, or you have a question about this, you could research it yourself.
Mm-hmm.
Remember, if you're feeling bored, curiosity is the cure for boredom. So find something to be curious about.
Mm-hmm.
I bet you've thought about things sometimes and said, I wonder why that is.
Mm-hmm.
Well, this is your opportunity to find out. You have the world information at your fingertips with the internet. And if you're curious about something, whether it's science or chemistry or physics or space or just anything, animals, you could find out about it. So find something to be curious about. You know, this is your opportunity when if you've ever thought, I wonder why that is. This is your opportunity to find out. Do you know many scientists learn things that way? They observe something and they say, I wonder why that is. And they do experiments and they change experiments slightly and they find out more and more about how the physical universe operates. So I hope you had fun today. Please join me Monday when we will talk about electricity, and I have some awesome things to show you. It's going to be a little more advanced than light bulb switches and batteries, but it'll still be cool and it'll still be not too difficult. And I hope you can join us then. Have a great weekend. Watch some videos that we've made before, and have a great day. I'll see you next time. Bye for now.